Hello students, Miss Slyman here with our next part of trigonometry. And this has to do with 3D shapes, and we've done a lot of this with Pythagorean theorem. And so this is really just now getting into the angles and such. So our cuboid has dimensions 20 by 30 by 40. So let's label those. 20, 30, 40. And of course, really I should have told you which one is which, so depending on how you label your diagram, you could get different answers, and that would be okay based on what's written there. And so the first thing we want to find is angle ABE. Well, ABE is on this front face. So I can make myself a separate right triangle, ABE. This is the angle I'm looking for. I'm going to make that my x. I know that AE is 40 and AB is 20. So tan x is 40 divided by 20, which is of course just 2. And so then x is going to be tan inverse of 2. And there I shouldn't have used approximate signs. I should have used exact. And then you can use your calculator to find the approximate. And I don't have my calculator with me, so you're going to have to do that on your own. All right, and then we also want to know angle ECA. Well, angle ECA, that's this diagonal that goes through the box, and then this hypotenuse on the bottom. So first we're going to have to find that hypotenuse. So if I draw that separate right triangle, I have EAC. So EA is still 40, but now AC is the hypotenuse of this triangle. And so AC is going to be the square root of 20 squared plus 30 squared. So that's 400 plus 900, square root of 1300 is what AC is going to be. I want to find angle ECA. I'm going to call that Y. And again, I'll use tangent. So Y is going to be tan inverse. The opposite is 40 again, and now the adjacent is that square root of 1300. And again, you'll have to use your calculator to get the approximate value for that one. Okay, so this one we're looking at a pyramid, and we've got that AB is 12. That's a slant height. BC is 8. CD is 4. So notice that here our pyramid is not symmetric. So we've got different measurements that we're going with. And we're trying to find the length of height AF. So we want to find AF. I'm going to label that X. So I see a right triangle that I can make with AF to FB. Then this part FB is going to be somehow connected to my FBD area, but it's not going to be symmetric, right? But I do know that F is going to be halfway between B and C and halfway between C and D. So that means I can put in a right angle down here that has 4 and 2. So that's going to let me, for 2, I can find my BF then. So BF is going to be the square root of 16 plus 4, square root of 20. And then looking at my bigger triangle, that is BA down to F. There's my right angle there. We know that BF is root 20, and we're trying to find AF. And now I can just use Pythagorean theorem with this one because we know that this is 12. So we're going to have x equals x squared 12 squared minus root 20 squared. And then we can figure that out. Of course, 12 squared is 144. Root 20 squared is just 20. So x square root of 124. I'm a little bit concerned that I've thought about this incorrectly. So if somebody thinks about it a different way, then please go ahead and post it. Oh, you know what I think I've done wrong? Saying that this is going to be a right angle here, because we don't know that this is necessarily a rectangular base because it doesn't tell us anywhere. So think about how this might change, this 4 and this 2, if we don't have a rectangular base at the bottom because we weren't told rectangular base. So think about that, and we'll talk about it more in class on Tuesday.